Hi everyone, this is me, Gleb, and I'm glad to see you. Welcome to Data Science Exercises again. Today, how to find optimal threshold, how to find optimal cutoff. Yes, so last time we produced the ROC curve, yeah, and basically it consists of all possible confusion matrices, yes, which you can observe here, yeah. But how can we how do we get these confusion matrices? Yes, we take all possible thresholds, yes, and convert probabilities into zeros and one using these thresholds, using these cutoffs. Okay, and now, yes, but if we want to use our model, our classifier, yes, is binary classifier, yes or no, yes. So what threshold should we pick? How to find optimal one? This is the question. And today, how to determine it using ROC curve. And actually, that's very intuitive. This is very intuitive. Let's analyze this. Let's analyze this curve again. Okay. So we start from the threshold 0. Okay. Oh, by the way, yeah. Let me. Yeah, here it is. So here is the scatter version of ROC curve. It's better. It's better describes what I want to show you. So here we start at a threshold. We start at a threshold 0. Yes, and we and kinda yes we predict all examples as positive one. Yeah. So we have the true positive rate. Yes, here's let me make a label TPR. True positive rate as at maximum. Okay, and false positive rate is at maximum 2. So, and another way of thinking about these two metrics, yes, this is the benefit, and this is the cost. Then we start to increase the threshold. And that should be obvious, yes, that increasing threshold, our classifier loses ability to detect, yes, because some positive example now missed, okay, but at the same time, the errors, the costs are going down too, okay, and as we increase the threshold, benefits are going down and costs are going down too, and we want to find the optimal threshold, yes. And where is the optimal threshold? That's obvious. The optimal threshold, optimal cutoff is there where benefits are at maximum and costs are at minimum. Easy, yes. So we could write it that way. Sorry, what is it? Benefit minus cost goes to maximum. And yes, in terms of true positive rate minus false positive rate goes to max. Yeah, and that's the very intuitive stuff. So we want to minimize errors and maximize profits. That's easy. So and we will calculate this point. Yes, that's like not a big deal. But another way to find an optimal threshold, yes, is to find the point on this yes, on this curve, which is closest to the upper left corner. So the distance is this, yeah. So we may also calculate all distances from the upper left corner to each point. to each threshold, and then find the minimal one. It's just the intuition to analyze it visually, okay? So because when we working with a plot with a chart, yes, we should use it like in intuitive visual way, yes, and that's the intuition. So and we could immediately, almost immediately see that this point is closest, yeah. So that's the optimal threshold, 0.43. Okay, but it could not be obvious all the time. Let me show you. So that's why we have to like calculate the numerical representation. Here is, for example, yes, on this ROC. This ROC is like looks very real. In real life, you will work with something like that. And here is it's like it's hard to determine where is the point is, which point is closest to the upper left corner. Because, for example, for red one, I think it's something here, yeah. And for green one, it's harder to say, maybe there. And for a black one, maybe something here. I don't know. So here is, yes, we have to perform a numerical analysis. It's not that obvious all the time. But again, it could be helpful, and also it's good to have this intuition. Okay. So now let's calculate this optimal threshold numerically. Let's create a copy of this notebook. Save copy in Drive. And as usual, I will get rid of a part of this notebook. So here is calculation of confusion matrices. Here is the ROC, and let's get rid of this stuff. Yeah, so here is the like calculation of area under the curve. That's from the previous one. Bam, delete, cool, add point, and now run all before. Runtime run before. California started to work today. Okay, so now let's look again at the table with this at the table with confusion matrices, and now I want to find the point where the true positive minus false positive rate has a maximum. So first of all, I have to calculate this. TPR minus FPR equals CM TPR minus CM FPR, like this, yeah. Now, let's just make sure that we have this new column. Cool. And now to get the optimal threshold, yes, the faster way for me is to just sort this table by this new column. TPR minus FPR ascending equals false. And now the maximum one should be at the top. And we can see, yes, that confirms our visual analysis. That's the threshold of 0.43. And here is, yes, this value where which we determined as the good like indicator of the optimal threshold. Yes, where the benefits has its maximum and the costs has its minimum. Yes, but I mean the combination of this. So that's like intuitive way how to do it. Yes, very cool, I think. There is also something called Youden J statistics, but basically it's the same thing as we calculated now, but only it's like it's the same stuff, but in terms of specificity. Yes, but what is specificity? Yes, so sensitivity is true positive rate. Here you see true positive rate. The other name for it is sensitivity. Okay, and specificity is true negative rate, but we can convert it into false positive. Yes, and that's 1 minus false positive. Yes, and if we can just rewrite this formula, yeah, like this, and we will arrive at the same statistics. But for me, it's like more intuitive to have my. So here's I will write equal TPR plus, and specificity is 1 minus F false positive rate, FPR, yeah, and minus 1. And if we open up brackets, ones cancel out, and we end up with FPR true positive rate minus false positive rate. That's the same stuff, actually. Yes, that's my statistics that I calculated. But for intuition, it's more convenient. And by the way, also we could make this Youden J statistics more convenient too, because the only confusing thing here is this one, this minus 1. Yeah, because sensitivity, yes, that's recall, it's a good stuff. And specificity, yes, it's also a good stuff. Yes, so we want these two values be maximum. So also you could remember it like that, because if we go, yes, to the receiver operating characteristic, here is the specificity. That's like the rate of true negatives. Yes, that's also a correct answers of a classifier. Yes, and we want both maximize true positive rate and true negative rate. Okay, but that's absolutely the same as say if we want to maximize true positive rate and to minimize false positive rate. Okay, so minimize errors. That's how you can think about it. Annotate, clear all drawings. Okay, and so that's kind of pure mathematical analysis of the thresholds. Okay, but in reality, it may be a little bit more complicated, because costs and the like positive outcome could have different price, different cost, you see. So basically, let me show you what I'm talking about. Let's look at this confusion matrix. So let's imagine, yes, that true positive, yes, that true positive brings us, let's say, $10. Yeah, and let's say that false positive costs us, I don't know, $100. Yes, so here they have different weights. Okay, and eventually we want to optimize the money. Yes, when we solve business problem, yes, we want to maximize our profit and minimize our costs. Okay, so when we are dealing with the real problem, yes, you have to calculate the this like errors in real monies. Find the cost for each outcome from the confusion matrix and calculate the final profit for each confusion matrix, and then find one with the maximal profit. Yes, easy. And let me show you an example. Let me show you an example. Clear all drawings. Let's say, yes, CM profit. Let's say, yes, as I said, that true positive brings us $10, okay, and the false positive costs us false positive costs us $100, okay, so that's the profit. And now I want to find the point with the maximum profit. Instead of sorting by this stuff, yes, I will sort by profit. And now, see, the threshold is different because the cost of error is much higher than the cost of benefit. We should be more careful with classification, yes, and so we have to assign one, yes, only for examples where we are really sure about the outcome, okay, means with the higher score, with the higher probability, with the higher threshold, okay. And it's a good intuition also, for example, for legal cases, yes, for criminal cases. We only say yes when we have a higher, we are sure very much, you know, we have a lot of evidence. Yes, so because the cost of false positive is very high, yes, to say that innocent person is guilty, yes, it's very high. So the threshold should be very high here. So for your business, yes, the same. You should analyze it in terms of costs, and you also may have the cost not only for true positive and false positive, yes, but for each outcome from the confusion matrix. Okay. So true negative may have its own cost and false negative may have its own cost. And then you summarize these costs and benefits and find the maximal one. I think that's really cool. And also, by the way, you can find optimal threshold in terms of whatever metric you want to calculate from confusion matrix. Yes, it could be like anything from this menu here, yes, from this sidebar. And you, for example, you may want to find the optimal threshold with maximal F1 score, for example. Yes, so, and that's again, that depends on your business problem. Also, I want to show you today a little bit example more close to a practical life, because in practical life you will never calculate confusion matrices by yourself, yes, manually. What's the point of it? Scikit-learn has its own implementation, yeah. So, but same stuff you could let me show you. Here is in the ROC AUC 21. I have calculated it from Scikit-learn. Where is it? Scikit-learn. Where is my Scikit-learn? Yeah, here is it. Here is it. So instead of doing it all manually, you could import ROC curve. Then you calculate the all false positive, true positive, and threshold for your data. So, and here is Y score. And then for convenience, I save it to a data frame because it's easy to analyze. Yes, instead of having 3 separate NumPy arrays, yes, it's more convenient to have it in one data frame. Okay. And so here is the same stuff. Yes, you can find the TPR minus FPR equals TPR minus FPR. Yes, and now you can sort this table, sort values, TPR, FPR, and here is the ascending equals false. And you can determine the optimal threshold. But here is the different one. Lol. Let's, by the way, let's plot it. Let's plot it in terms of points. Like this. Bam, and see why is it different. Oh yeah, I know why is it different. Because let me plot it. Have anyway. Anyway, here is, I will choose it for T. Because as we figured out in the previous episodes, the scikit-learn predicts the 0 and 1 using greater or equal, yes, and I do it using greater. Yes, for me it's, I don't know, for some reason it's more intuitive. You see here, where when I produce my predictions, yes, when I convert score into predictions, I use here is the greater, yeah, and scikit-learn uses greater or equal. And let me show you it. So the curve absolutely the same, okay, but you see it starts from in scikit-learn, it starts from 0.17, okay, and I start from 0, but next goes 0.17. That's because I make my predictions using just greater, and scikit-learn uses greater or equal. And again, yes, the point is the same. Yes, here is the just 0.5. I have it next to the 0.43. That's absolutely same. Okay, so just keep it in mind. But actually, for like huge data sets, it's like it's not a big deal because the probabilities are really close. Yes, and you will be off by like a small, a very small number. Okay, so for this small data set it could be a big deal, but for a smaller for a bigger data set it's not a big deal, and you could just don't think about it. Okay, so that's how you can use the standard implementation of ROC curve to find the optimal threshold. Okay, and also, yes, for example, here we don't have the confusion matrix, okay, but we can deduce it back. For example, yes, true positive rate, if we go to formula, we could find that it is true positive, yes, divided by true positive plus false negative, yes, and we know the number of all positive examples, and we could just like multiply this TPR by number of positive examples and return back true positive. Yes, if you want to perform the cost analysis, yes, like as I showed here. Yes, you can calculate this like stuff from confusion matrix. Okay, but also you can use these thresholds to like calculate confusion matrix using the again standard implementation from scikit-learn. Okay. So that's it. That's how you find the optimal cutoff, optimal threshold using your ROC curve. See you guys. Have fun. Thank you.